Hello and welcome. This is Steve Stuffoletto from Erie Community College in Buffalo, New York. Today's topic is flexography, frequently just called Flexo for short. It's a basic introduction, really designed for beginners or people that are novice. So this is an interesting topic because there is no real digital replacement for packaging. You're not going to find cornflakes, Rice Krispies, or Cheerios on a USB stick or a CD-ROM or something like that. So no matter what happens to the printing industry, packaging industry is still going to maintain a positive, strong growth, unlike other segments of the industry like commercial printing or publication printing for books, newspapers, and magazines that often use sheet fed and heat set web offset lithography or even cold set lithography. So in 1951 the process was renamed to flexography or flexo based on an industry survey, a poll, and partly that's because the plate material itself is flexible and the substrates that we print on, the plastic films, are flexible. The printing process itself is a raised relief, so it's very similar to rotary letterpress in that aspect in terms of the image carrier or the plate. There's been many recent advances in the technology, and the plates allows us to run finer screen rulings and LPI. We can print smaller, finer minimum highlight dots. The Anilox rolls have improved, the inks have improved. So all these improvements in the process and the raw materials now is putting more competition against lithography. So today the market share for flexography is about 20 to 25% of everything that gets printed, dollar volume wise, and the growth trend is positive. So we're expecting to see, 4.5% growth every year in flexography. Again, because it's packaging, not commercial printing or publication printing. And Flexography's Anilox is so predictable in terms of its ink film thickness that we now see Anilox rolls used in sheet-fed offset lithography for either pre-coating or post-coating, often done in line. So there's basically three types of products that we use for flexography. Corrugated, which a lot of people just call cardboard, that's fluted walls, so it's often used for pizza boxes and things like that. Then there's flexible packaging, which can be bags, like bread bags, pouches, sleeves, shrink sleeves, wrappers, candy wrappers, things like that. So the definition of flexible packaging is that it can change its shape, it's not rigid. So that's flexible packaging. And then there's folding cartons. So flexography is used in all three: corrugated, flexible packaging, and folding cartons, as well as labels. Now labels, we call it roll stock. So if you look at this illustration here, you can see KISS die cut, pressure sensitive PS label stock here. So this is called roll stock because the labels are on a roll and then they later get applied to the container. So the markets that flexography serves is food and beverage. Just think about all the soda and pop cans, whether they be metal or plastic. Those bottles all have labels on them. Think about all the household and personal care and cosmetics packages that have labels on them. Pharmaceutical, of course, and then all the consumer product companies, which we often call CPC, or the consumer packaged goods, which we call CPG. Think of people like Procter & Gamble, P&G, Kraft. These are very large companies that purchase a lot of products that we buy in the supermarkets, the grocery stores, the retail stores, and things like that. So if you walk into a grocery store and you walk down the aisles, I don't know the exact percentage, but the vast majority, 70, 75, 80% of all that packaging, that flexible packaging, is done by flexography. So here's some additional resources for flexography. You should go to the Flexographic Technical Association. That's their website. They're often called the FTA. Then there's FIRST, F-I-R-S-T, which is the Flexographic Image Requirement Specifications and Tolerances. I think they're in version number 6, which was published in 2017. This is a very good document. FTA publishes their own magazine called Flexo Magazine. It's in print and there's a digital online version. And then if you go to online internet websites for job placement, like Indeed, you often find NPPS. They're a recruiter, and NPPS is the National Printing and Packaging Specialists. They're basically a recruiter. There are several colleges across the country that have Flexo programs with Flexo printing presses. Clemson in South Carolina is well known. Fox Valley in Appleton, Wisconsin. Dunwoody in Minneapolis, Minnesota. RIT, Rochester Institute of Technology, right here in Rochester, New York. And then Ryerson up in Toronto, Canada. These all have Flexo programs with Flexo printing presses. Some additional resources, if you want to look at some videos on YouTube, there's several here. You could just do a search, Google search, and find other videos. Okay, now let's look at the mechanics of flexography. It's a very simple, basic process. We have a trough that has a fluid liquid ink in it. There's a pickup roller or a pan roller that brings the ink to the Anilox roller. The Anilox roller is a uniformly engraved, etched pattern, kind of like a knurl. The ink gets scraped off with a metal or stainless steel doctor blade that scrapes off the excess ink. That ink on the Anilox then gets transferred to the relief plate. So let's take a close-up look here at the interface between the Anilox roll and the relief plate. The Anilox has these cells or wells, cavities, that get filled with ink. It contacts and touches the relief plate and transfers ink to the top raised images. Then we transfer directly to the substrate or the paper or the plastic film. So the similarities to rotary letterpress are that you have a relief press in your rotary web or roll, and that's about the same, that's about the same similarities. After that, the differences in the Anilox roll. How do you identify flexography? Well, we know this pretty well. If you take low power magnification, magnifying glass, and look at the edges of all type, you will see a halo ring, an outline, a stroke, a border, and that's because the ink that's sitting on the top raised relief, when it gets impressed or squeezed against the rubber photopolymer plate, the ink gets squeezed out to the outer ends and starts to print not off the top but off the edges, and that gives you this halo ring. So this is the most identifiable characteristic of flexography. Now if you go to the quarter tone dots, you'll also notice that the dots are typically hollow in the inside center. So that's another identifiable characteristic for flexography. The plate is a relief plate, so there's a physical mechanical separation or distance between the image areas and the raised areas. The raised areas are image, the sunken recessed areas are non-image areas. The plate is made out of a flexible rubber or polymer, a plastic basically. The thickness of that plate is usually around 0.067, maybe a thinner plate, 0.045. But those are the two most common thicknesses of the plate material. The plates can be made analog with film, or they can be made digital. If they're made with film, analog is a photomechanical process. You have to expose the plate and then develop the plate, which we often call washing out or scrubbing out the plate. The two most popular plate manufacturers are probably DuPont, that makes the Cyrel plate, and Kodak, that makes the Flexo plate. Digital plate making is CTP, computer to plate, using some type of a laser here. Now, one interesting thing about this Flexo plate is that when it's flat, it's at the correct dimensions, but when you mount it onto the plate cylinder and that curvature, you now have to compensate for the elongation or the stretch of that plate getting longer. So you have to do some type of anamorphic compensation and pre-press, a scaling, if you will, to make sure that that plate now fits whatever your die cutting image is. So a typical distortion factor might be somewhere around 95%, something like that. 95% smaller to compensate for the elongation or the stretch. Now that we have this plate made, it has to be mounted to a cylinder. So these cylinders have variable diameters for variable different repeat lengths so that we're not wasting paper in a gap. The mounting is done with a double-faced tape called sticky back tape. We can use sleeves instead of cylinders so that we can preserve the labor of the plate mounting. And this is all about kiss impression. So if we went back to that mechanical illustration of the process, you have kiss pressure between the plate and the Anilox called squeeze, and you have kiss pressure between the plate and the substrate called impression. So it's all about having the least minimum amount of pressure to transfer the image. The ink in flexography is a fluid liquid. It can be water-based, where you have to be concerned about the pH. It can be a solvent-based ink that has VOC, volatile organic compounds. 25% of the ink market is solvent-based inks. So you have to go through some type of a heater, dryer, or oven to evaporate or flash off those solvents in the inks. And then we have UV ultraviolet radiation cured inks, which are also very popular, especially for narrow web presses. So these inks are fluid liquids. They have a very low viscosity. So we can measure them with a Zahn cup. And a Zahn cup has a fixed volume with a hole in the bottom. You would submerge the Zahn cup into the ink, pull it out, and with a stopwatch you would time how long it takes for this cup to completely empty and drain. When that happens, you would note the time. So typical viscosity of our Flexo inks are somewhere between 25 and 35 seconds using a number 2 Zahn cup. This is unlike sheet-fed offset inks that are thick pastes and are very sticky and tacky. The heart or the key to flexography is the Anilox roll, and it's a ceramic coated roll that's laser engraved. So the surface, if you look at the surface under magnification, it's got this honeycomb, this bee honeycomb shape to it. These are very tiny miniature cells, wells, and cups that get filled up with ink. So we meter the volume of the ink in something called billion cubic microns, or BCMs. Then we have a stainless steel metal doctor blade that will squeegee the outside of the surface clean. The ink is inside the cells, of course, so we can measure its ink film thickness in BCMs. So on narrow web, we have a pre-metering rubber roller that squeezes up against the nip, and then on wide webs, we often have a closed chamber dual doctor blade to help prevent evaporation of the solvent-based inks. Substrates in flexography, again, so flexography, you can think of it as being a flexible plate. You can also think about it as being flexible materials, substrates. So these are typically non-porous plastics. So there's all types of substrates. We have a lot of flexibility and choices and options. They can be paper-based, which are good for water-based inks. They can be a plastic film. That film can be either clear, transparent, or it could be an opaque white. These films could be laminated or vaporized with aluminum metal, so they're metallized foils. A lot of the substrates in narrow web for labels are pressure-sensitive PS. They're an adhesive where you kiss die cut them and separate them. So you have the face and you have the liner. You could surface print, which means the image is on the outside top, so the image is right reading. Or you could reverse print, which means you're printing on the back side of the clear film, so the image would be wrong reading. The plastics or polymers, these are films. So typically, if you think about plastic drinking bottles, soap or pop or soda bottles, they have a recycling ID code on the bottom. So most of these are not biodegradable, but there's been some recent advances in having biodegradable plastics. And some flexo printers are so large that they can actually extrude and make their own plastic rolls. I have a spelling mistake here. I apologize. I'll fix that typo later. So the plastics can be polyesters, which is often called PET. It could be a polyethylene, PE. It could be a low density or medium density or a high density. It could be a PVC, polyvinyl chloride. It could be a polypropylene, PP. Or it could be a polystyrene, a PS. So those are many different choices for the film substrates that we have. Let's look at the basic design of some of the flexo printing presses. There's three. Almost all the flexo presses are web or roll, so they're rotary. They can be stacked vertically. They can be inline, which means they're horizontal, station after station after station. That's typical of narrow web, 20 inches or narrower. Or they can be a CIC, common impression cylinder, or central impression cylinder, which is really for wide webs, 70 to 80 inches wide, typically printing on one side only at much faster speeds. And on a CIC press, you often have sometimes called a satellite press, because the roll of material comes in and it wraps around a single common central impression cylinder where you have your plate, your Anilox, and your roll supply, your ink supply, your pan roller. Then you dry. Then you go to your next color, plate, Anilox, pan roller. Then you dry. Then you go to your third color, your fourth color, your fifth color, and your sixth color. And because we want to do interstation or inter-deck drying in between here, so we're dry trapping as we go around. Some of the press manufacturers, people that you will hear of, are Mark Andy, very popular. Galis, again, very popular, now owned by Heidelberg. Comco, MPS, Nil Peter, Bobst, F&K, MPS. These are all different types of press manufacturers. Some printers, some flexo printers are also called converters, because they're not only printing, but they're also converting into bags. So you're often called these very large flexo printers converters. Okay. So who are some of the flexo printers in Buffalo, New York? We have several. We have Resource Label Group, who formerly was called Ginsler Graphics. They were purchased in 2017. You have TapeCon, right downtown Buffalo. Resource Label Group is out by the airport. CP Flexible Packaging, who used to be called Flexo Transparent. They were just purchased last year in 2019. They're right downtown on Seneca Street. CCL Labels Industries. Pro-Am Pack, who used to be called Trinity, who used to be called Celopac. Celopac sold to Trinity in 2013. Trinity sold to Pro-Am Pack in 2017. Bison Bag up in Lockport, Cascades, who was formerly AIM Corrugated, and then in 2004 they got sold to Norampak. Cascades or AIM or Norampak are corrugated box printers. Buffalo Envelope for printing on envelopes. Ashton Potter for security printing. And Nissa Medical Technologies, who used to be called Graphic Controls, they're right downtown Buffalo too. They were purchased in 2016. So there's a lot of printers here, right here in Buffalo. And again, if you go to Indeed and look, you typically find a lot of these jobs posted. So thank you very much. I appreciate you watching this video, and I hope you found it interesting and informative. Until the next time, have a good day. Bye now.